All right, welcome to lesson 5.06. Here we're going to continue working on comparing exponential functions with other function types. I'm going to go ahead and give you a couple of problems here to work on and let you try them on your own. Then I'll give you a couple of hints to help you check your work and move forward if you got stuck at all. But I want you to persevere in solving these problems and making sense of your answers so that you're able to determine whether you think your answers are correct. This will be great preparation for the quiz. All right, so here's the first question. Go ahead and copy down the relevant information and make sure that you create a very clear table here for the average rates of change and explain the average rates of change in part B. To help you make sense of your answers here, consider the types of functions you're dealing with and go back and review, or do so by analyzing these functions here graphically, what occurs with the rate of change for these types of functions so that you can determine what you'd expect to see in each of these situations and confirm that that's actually what happens. Let's go ahead and move on to the next problem now. Okay, here's one where we're comparing three different trees, tree A, tree B, and tree C. One thing that I want to point out is the function here. The exponent is t divided by 2. That's all in the exponent. So it's 15 times 1.69 raised to the t over 2 power. Okay, just to be very clear there. And this is the graph of h of t. So go ahead and copy down the relevant information for tree A, tree B, and tree C, and then go ahead and answer the following questions here. I'll give you a couple of pointers and tips for how to check the reasonableness of your answers in a couple of seconds. Okay, so you should be able to identify the linear function here pretty easily. I want to remind you guys of the average rate of change. So for example, let's say we're finding the average rate of change of the function f between, let's say, 1 and 2. Well, what I'm going to do is I'm going to find the change in y, which is the value of f at the point furthest to the right, which is 2, minus the y value furthest to the left, which is 1. So it's f evaluated at 2 minus whatever f is evaluated at 1, and then divided by the change in x, and that is going between 2 and 1, so it's 2 minus 1, which of course is just 1. And then whatever you end up with, that is your average rate of change. Consider the units here. It's whatever the units of the y value are per whatever the units of the x values are. So make sure that you're including both of those. In this situation, we notice that the y values are measured in feet and the x values are measured in years. So that should allow you to make sure that your units are correct. Last but definitely not least, when you're using the properties of exponents here, my hint for you is to take a look at the exponent t over 2 and to see if you can rewrite it in a way where you just have t. I'm not going to try and leave it at that because I want you to struggle with it a little bit, go back and review some of the exponent properties that we discussed back a unit ago and see what you can come up with. Then we can take a look at it together in class.